So first of all, welcome everybody to us here at Vox Days Zurich. And it's really happy to be here. And also especially for me and Grace, we used to work together at IBM, and currently I'm at DataStax. But today's topic is about stateful microservices. So we're going to explore stateful microservices in the cloud-native world. Okay. And first of all, if you're interested in this slide deck, it's already available here. It's shared on this link. But we will make the slides available afterwards, too. So even if you miss, you can get it later. OK, so let's have a bit of introduction. We have Grace here today.
Hi. Yeah, so my name is Grace Jansen. Lovely to be here with you all. For those of you who haven't met me before, I'm a developer advocate. And if my accent didn't give it away, I'm not from Switzerland. I'm from the UK. And yeah, Mary and I used to work remotely on a team together. I have a slightly unusual background. So although I now work in sort of cloud-native Java technologies, I actually did a biology degree previously. So come from a bit of a different route in. I like to incorporate that in my talks. And yeah, passionate about women in technology and love to travel. So it's great to visit Zurich. Nice to be here.
Great. Thank you, Grace. So, and that, oops. So it's like, OK. A bit about myself. My name is Mary Grygleski. I'm a senior developer advocate at DataStax now. My area, I'm into streaming, event streaming, NoSQL now, and some open source as well, Apache software. I'm also a Java champion, and also I have over 25 years of actual hands-on software development engineering experiences. I was previously a senior developer advocate at IBM with Grace, as I mentioned earlier. I'm also a very active community organizer. So currently I'm the president of the Chicago Java Users Group, and you're all welcome to join our sessions as long as the time zone will work out for you, the time. So, OK, so that's a bit about myself here. And so let's get into our topic. It's about stateful. First of all, we'll kind of set the stage to make sure everybody were on the same page talking about stateful microservices. So we'll give you a bit of a background. So bear with us if you're already familiar with this topic. So about stateful and stateless, we'll have Grace start with giving a bit of a background.
OK, so who has seen Finding Nemo? Oh my God, OK, I thought there were going to be way less hands than you panicked me. OK, so if you haven't seen it, it is a must-see. Please go and watch it. It's a great Disney movie. But we're using this analogy today between Marlin and Dory. So if you think about sort of this definition between, OK, what does a stateful microservice mean and what does a stateless microservice mean? And so we've got Dory, who sort of represents this more stateless view of the world. She doesn't really remember much, and so she's able to react to things in real life a lot quicker because she's not necessarily thinking about, oh, what are the consequences of jumping on a jellyfish, for example, and all of these kind of things. Whereas Marlin is... he's got a great memory, don't get me wrong, and he's able to remember all of these fantastic facts and memories of his life. However, it does make him a little bit slower because, when he's looking at a jellyfish, he's thinking about, okay, am I going to get stung if I jump on that jellyfish? What happened last time I interacted with a jellyfish? And so we've sort of got this analogy between stateless and stateful microservices where you've got benefits to each, but they're able to exist in harmony in this sort of ocean environment. So previously, computing life used to be a lot simpler back before we started thinking about all this sort of cloud-native technologies. And so we sort of had previously more stateless computing. So when I talk about stateless computing, what I really mean is sort of this communication protocol that means we're not recording or retaining any session information. So the state of the data doesn't get recorded between those transactions. When it comes to the architecture, really this means that it's much easier for us to be able to scale our system, and recoverability from system failure is also a lot easier because you don't need to be worrying about reinstantiating that microservice to the same state as when it failed or crashed, for example. So it can be a lot easier for that. However, realistically, we live in a stateful world. Who's ever forgotten a child or a spouse's birthday before? Because the consequences aren't great. Yeah. We live in a society where we are expected to remember dates, important dates. We're expected to remember important information. What's your name? Where are you from? What company do you work for? All of these important things we ask at conferences. So really, we live in this stateful world, and so it's important that our applications, naturally, it makes sense for them to reflect that stateful nature. And so we have stateful computing. So what I mean by this is where we do retain that session information. So the state of the data does get recorded at every step across all your transactions. And when it comes to architecture and design, scaling that system becomes a little bit more difficult. And also recoverability, it involves a lot more effort. Because again, you have to be worrying or at least concerning yourself with this reinstantiation of microservices that have perhaps failed and you have to bring back up again, bringing it into the same state. So this is where we've gone from sort of stateless to stateful. We're more reflective of sort of the world that we currently live in.
Yeah. So now let's get then into a bit about when we talk about state, what are we actually referring to, right? It's really about the states of the data. So let's kind of understand, first of all, there are three fundamental state of data. And essentially, these state of the data are associated at essentially three different mode of operation. So one is data at rest. So that's when you can think of data at rest is maybe already residing in a storage, persistent data store, such as some database. And here too, I'm at DataStax now. There's Cassandra. You're having data at rest. And usually too, they are just resting. It can be also at a data warehouse or data lake kind of scenario. It's kind of more stable, not changing. And then there's also data in motion. So that's when it's in transit. For example, especially in streaming type of applications, now we bring a bit too into the streaming side of things. When they talk about streaming, it's really like data in motion. They are actually traveling from maybe in a data pipeline from one source to the other. So things can change rapidly too, right? Your data itself gets updated at any point in time. When you deal with event streaming kind of data, it's really data traveling at points on the timeline, kind of like that. And then there's also data in use. Maybe you're already operating the data in some kind of services, a microservices. You are actually operating on it. You get some data from the source and then you operate it in. So that's kind of essentially three modes of the state of data that we're talking about. And then the role of microservices for the data, or at least this is how I interpret, right? Sometimes when we talk about, we're coming out now, we're reading literature as developers. Microservices are everywhere, data and everything is just all kind of confusing. So I want to kind of set the stage to microservices and, what is its role in dealing with the data? So microservices really is a place where we operate on the data, especially operating on data that's not at rest. So either in motion or they are in use. So what are kind of things that we can do with the data? How do we operate on? So essentially, too, you want to first of all maybe fetch the data from or place into some data source. So very often, if you do event streaming type of application that pops up, for example, you have a data source. So you read and write, right? And from there. The source, too, can also not just be a data pipeline type of scenario. It can be also on disk, too. You are doing some processing, then you read from some database. Or like I said, right, in memory, in transit type of database in a data pipeline, or in the cloud too. Well, we know that, cloud isn't really a cloud in the sky, it's just some disk, right, in the center, a big data center that's shared kind of place. So data source, like read and write. So essentially too, how does the state gets changes when there's I/O that's get triggered, right, and then to make things happen, and then it will trigger some changes in the state of data. And also, too, that's where, too, when you're in the microservices, very often, too, you get the data, then you operate on it. Operate by transforming the data, for example, filtering it off, and then ship it elsewhere. So that's kind of what the role of microservices is, right, in today's world for the data. Okay, so then now let's talk a bit then about statefulness in the cloudless days. So let's kind of go back a bit in history, meaning that before microservices, how do we deal with statefulness of data, right? So first of all, I think a lot of you maybe also have worked with EJB, right? And those, I think it's still kind of being used too, right? And so let's say, right, before all the cloud, essentially we're in kind of client server systems. If we go back in time in kind of just a near past. So when we're working with stateful data, very often too we rely on databases to manage all of these states. So and then when we deal with stateful transaction kind of operation too, we also very often are bringing into concepts of transactions. And then we will rely on the database, and especially relational database already have built-in like transactional kind of support. So it's all done on the server side. And also, too, I want to bring up, too, very often, if we're kind of in a simple scenario, we may be dealing with only one database. But the truth of the matter is, sometimes if you deal with big kind of enterprise system, then we're dealing with multiple databases. They don't necessarily have to be of the same version or same vendor, but also, too, can be of different vendors. They participate in the same larger transaction within an ecosystem. So how do we kind of manage, right, the state of data that kind of like travel between different network boundary, different disk and all that? So that's when a protocol called two-phase commit was kind of more popular back then. But as it is so too, we realize that it isn't the most ideal way of dealing with like distributed transaction. The reason is that while two-phase commit kind of works too, because two-phase, as it implies, right, it deals with transactions that span across different network boundary and different databases, different kind of operating environments. So essentially, it's two-phase. You need a coordinator being there and kind of collecting all the votes from all of your different entities. Let's say we take an example of multiple databases. You have database one, maybe can be a Sybase, and another one, Cassandra, or an Oracle database, and you have to collect votes from each one of them and say that, well, are you done with your transaction? Are you're updating some data? You also have to make sure it gets updated properly elsewhere. That's kind of within your same business operation. You have to then coordinator will have to go to each one of them and say, are you ready? Is it good? And if it is good, the coordinator will collect all the votes. And then when it's all good, after you read the results from everybody, if it's all good, then the coordinator will tell each one of them and say, commit, 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 commit. So as you can see, it's very synchronous type of doing things. It's not very ideal. So it is still actually being used, two-phase commit protocol. It works, but it's just a bit slower. So that's one way of dealing with stateful transactions, right, in the older days, not so old, but okay. And then there's also Java. So in the Java world, we know that in enterprise EJB kind of usage too, in EJB, we can do enterprise Java beans that actually have stateful session beans or entity beans too. These actually help too with persisting the data to the database. It's actually more the enterprise level of, actually I should say entity beans. Because you also can have stateful session beans, but they only last during the session when you are kind of, in kind of transacting in your operation side. So that's EJB dealing with like stateful transactions. And then on the website, then in Java, there are servlets, and you leverage on HTTP session to help you to persist the state. But as such, too, HTTP is a stateless protocol. So then you're relying then also on some cookies, perhaps, and different caching mechanism. You could be doing things like using Hazelcast, for example, or some kind of external way of Redis, for example, managing your cache data and helping with HTTP type of transactional case. And then there's also, as I mentioned too, on the client side too, you can also do caching, like of server responses. So say cookies, which I kind of mentioned already, or you can also leverage on like token-based type of authentication, for example, too, that helps you to kind of preserve data as they kind of transact, through your complicated, especially cloud-native world. So those are the ways you can do like transactional support, stateful kind of transaction. Okay, so now I brought up too about the fact that we live in a really kind of more complicated world, cloud native, right? That's we bring this into the picture. So there's another kind of challenge that now we have to solve with the cloud native. But first, let's take a look and understand what cloud native means, right? The environments is so complicated. So we'll have Grace kind of talk about that.
Yeah, so where does this all fit in? You might be scratching your head thinking, okay, when I think of cloud native, all the definitions that I take a look at or documentation that I'm taking a look at telling me, I should be using stateless containers if I'm trying to build effective cloud native applications. But is this really the case? Do you have to have one or the other? Can we create effective stateful microservices that can still be deployed effectively to the cloud? And actually, when you take a look at that sort of original definition of what does cloud native computing really mean? So really, this was sort of coined back in about 2010 by Netflix. So it is kind of biased to what they were creating at the time, but it does stand as a good sort of introduction of this is what we were intending from this in the first place. So really, this is about creating this sort of extension to cloud computing by addressing these true needs. Now, what do we mean by true needs of sort of enterprise-level applications? Well, there's 3 key needs that Netflix identified, and that's being highly available, being scalable, and being performant. And the thing to note here is nowhere in that definition do we state it has to be a stateless microservice. And a lot of the cases in our applications, we might be able to use stateless, but we might have to or prefer to use stateful. So how can we create stateful applications that are sort of enabling these key behaviors, this high availability, this scalability, and this performant nature of applications that we want in the cloud? And really, these key characteristics are, not reflected on the board. I don't know what's gone on there. There we go. Oh. It's the classic turn it off and on again. So yeah, these behaviors are reflected again and again in various different vendor definitions of what it means to be cloud native. Am I still okay? You guys can still hear me, right? Yeah? We'll carry on. Ignore there we go, it's gone. So yeah, so I took basically a load of different vendor definitions from various different cloud native vendors, ranging across from foundations through to proprietary companies, and sort of took out all of the parts of their definition that was specific to a language or a platform or a particular toolkit. And what I was left with was this word map of the same types of behaviors. So having that high availability, having rapid microservices, being able to bring them rapidly up and down, scalability, being able to observe them, having this resiliency built in so that we can keep them being performant. So again, these are the characteristics that we're striving towards. And again, we can potentially achieve this still with stateful microservices. And taking a look at factors like the 12-factor app methodology, you guys come across that? I'm hoping a lot of nods, yeah. There's also the extended 15-factor app methodology. If you haven't taken a look at that, that adds an additional 3 factors. But in here, this sort of mimics those behaviors that I was showing in the previous slide about this, these key characteristics we want to be seeing in effective cloud-native applications. If you've not come across the 12-factor app methodology, you can go to 12factor.net, and it goes into great detail about each of the factors. Here's just a list of each of them, and you can start to see how various different factors here in this list can enable us to be able to achieve those factors. So for example, having external configuration and storing that config in the environment instead of in the application can enable us to have this flexibility to go between different cloud providers and various other things. Now, the note here is we do have processes, as you can see here, which does say about executing the app as one or more stateless processes. But again, it's that word processes. A process does not necessarily mean a microservice. So in this case, again, we can still build applications that have state using methodologies like this to sort of get those behaviors into our applications. But the question now is, okay, we know what we're striving to achieve. We want to be achieving these key characteristics, and we know that we can potentially do that with stateful microservices. But how do we go about preserving state in a cloud-native way?
Mm-hmm. Okay, so let's then go into some of the first, right? I like to kind of look at this, right, from different angles. But let's first look into the techniques, some mechanisms we can use. So I brought up too, as I was talking earlier, you can use caching to do it, right? And caching too, like let's say you can do client side, like if you want to like cache, and actually then there's actually cookies too over there. So, okay, so caching too, as such, right, on server side, you can rely on maybe like something like external, like Hazelcast, because I have an example that I can show you too. You can leverage on Hazelcast to help you with caching. And cache essentially too is just, keep things in small chunks and in memory while you're your system is in the runtime, kind of caching. And then there are also database transactions too, database style transactions that you can use, right? On relational database, they are almost all you can, if you do any kind of like insert, select, update, delete, that already starts off, if you don't specify, explicitly that you want user control transactions, it's usually the database, it defaults to it, also managing your transaction and then keeping the state of data correct, appropriately, right? So if something doesn't work right, you abort the transaction, then everything gets rolled back. So that's database transactions. And then there are also cookies too that helps you with managing the state, right? When you're doing like web, especially in web applications, you can have server-side or client-side cookies too, in which it keeps, server, when you make the first request, the server will send you some cookie, a small piece of identifier that the client will keep it. So the next time you submit any new requests, it will carry with it that cookie. So then the server knows, oh, it's the same client again requesting things, and I can kind of make relationship in the backend side or the server side. What it is referring to the same request from the same client. So cookies. And then, of course, too, there are sessions that are helping us to also like manage all of these different so to speak, operating kind of context, right? The sessions from different requests coming from different clients. You can group them by sessions. And then, of course, there are also tokens, too. They are very often, too, using an authentication type of mechanism. So these are more like kind of techniques and mechanisms you can use. Now then, we kind of bring it into the cloud-native world, then very often with the infrastructure getting so complicated these days. So,
I'm just going to change it. There we go.
Oh, okay. Oh, okay, thank you. And so, so I just want to point out too, right, in containers, let's say, right, cloud-native these days seems like everything is about Kubernetes now. Everything is about containers because they work really well. This mechanism works extremely well in the cloud-native infrastructure. So I just want to point out too, in Kubernetes, it has what is called too, these are things that I want to bring up, that's called like leader election. So that's actually very important in any kind of systems in which you have multiple, like a cluster environment. You don't want everybody to kind of be the leader, so to speak. And so you need to have a good algorithms in your infrastructure to kind of manage. So then only one instance, right, in a cluster environment, you can have all your processor duplicated. So you have to have that mechanism. It's called leader election. That algorithms is also already built into in Kubernetes if you want Kubernetes to handle it for you. Because Kubernetes has this thing called etcd, I guess, etcd, that already has this leader election. Now, this is actually important. I want to point out, especially in microservices kind of scenario. You want to make sure that all of maybe your data, your processor being duplicated or kind of in a clustered environment for a fault tolerance kind of purpose. But when it comes time, let's say you need to make a payment. I think that's a kind of classic example. You want to make a payment. And because you have duplicated maybe payment module, you don't want all of them to run at the same time. You don't want your customers to be charged more than once. So that's actually absolutely important to have the right kind of leader election algorithms built in. So only one gets to have the final say and submit the payment to get money and all these things. So that's that. And then in Kubernetes, let's get back now. Then in Kubernetes, there's also this concept of stateful sets too that you can also kind of configure your Kubernetes environment to work with. So as such too, it manages stuff so then you don't get duplicated, or actually how can I say, like you have like in a stateful environment, you can have like multiple nodes being spun up at any time. And so you want to make sure that they are all kind of maintaining in the right order. So if something goes down and you don't want to have things out of order, so this stateful sets too will have built in all of these things to manage the fact that your cluster environment have all of these nodes being kind of up and down. That would be one thing, managing all the versions. You'll be updating and kind of upgrading or downgrading some of the nodes. That stateful sets will kind of help you manage it too, and it's actually very important, especially in cloud-native environment. And I also want to point out when I do some demos or showing you things, because I also work with this new streaming platform called Pulsar. In fact, it also does very, very good in terms of doing rebalancing of all of your partitions, in your system. But I'll get more into that detail in a little bit. But okay, so Kubernetes will help you with stateful sets. And then there's also persistent volume too. So this kind of deals with like storage of your actual you kind of can manage like persistent volume. Where do you want to put the data in what volume, that type of stuff. So this all kind of be done like through configuration, configuring your Kubernetes environment. And then there's also another concept in Kubernetes called cookies and session affinity type of mechanism. So think of the fact that you have requests coming in, and you basically don't want, let's say it's kind of much, I should say, it functions much like your, going back to the days of just pure web. So you can have a request coming in. So in this case, right, in a request coming into your container environment, and you don't want another request coming in from, from the same context to, well, you don't want to have it to kind of completely be spinning up a new context to service your same request. So that's when you kind of use some kind of sticky session. So then you know that, okay, I want to maintain sort of like a persistent or temporary persistent connection for that session. So you kind of use this session affinity kind of mechanism in Kubernetes, where you can actually reuse the same kind of cookie and session to service the same client. So in Kubernetes, it has this mechanism for you to use. So sorry about that. Okay, and let me check the time. Okay, and now then, okay, we talked more already about the techniques and infrastructural things. So let's kind of get into a programming design pattern. And so when we're all developers, we tend to want to talk more about programming stuff. So what can we use, right? So from a programming perspective, we can actually leverage on a pattern called Saga Pattern. So Saga Pattern, essentially, it helps with you to do like distributed transactions quite well. And it helps, with the transactions being spanned across like multiple services. So think of earlier when I talk about distributed transactions, we're dealing with different databases everywhere. You need to want to maintain the transaction context between all of them. So Saga Pattern, if you employ that, is basically, it helps you with that. And essentially, too, Saga, as the name implies, right, it supports like a long-running type of transactional context, too. And it doesn't actually have a rollback type of concept. However, it's called compensation. It's a forward strategy. So then if, things can't always go right. So when it goes wrong, you have to have some way of compensating for what's already been done. You kind of, in a way, it's like rolling back, but it's not exactly rollback. It's just forward kind of strategy. So there are two ways, too, of doing sagas. One is called choreography, which is, I believe there's another speaker that was here earlier talk about this, too. So we won't get into all the details here. But the thing is, too, with Saga, you can have two ways of doing Saga. One is choreography, which is using an event-driven type of approach. So it's everything, too. Think of it more self-initiated kind of ways. And then there's also orchestration. And that's when orchestration, you're leveraging on a broker to help you, too. And then also, too, I wanted to point out on the right-hand side here, too, there's also a pattern called long-running action, which is essentially a Saga interaction pattern. And it's also making use of a compensator model. It's very similar. It's actually essentially Saga, too, but it's called long-running action. And we want to point out here, because MicroProfile, it actually has also this feature called LRA, long-running action, too. And then with that, let me kind of quickly show you an example of using a Saga pattern in the design. So let me kind of go over here. Actually, oh, sorry. Actually, it's over. Is it here? Sorry. Okay. I guess you can see here. Okay. Yep. Yeah. Okay. Let's do it like this. So just want to kind of illustrate, right? We're using Saga pattern. If we want to use like a choreography, event-driven kind of Saga, how would I do it? So over here, I just doing this shopping cart would be one good illustration to leverage on this. So if you think of it, we can also make use of something like a Kafka topic, or even now too, you can also use Pulsar, which is also a event streaming and processing type of platform, but anything. And anyway, it is an event-driven pub/sub type of way of doing things. That's where you gather all the information from some request that comes in. For example, in this shopping cart, some order gets generated from this topic. So from there, then, with the topic, you want to have the order, your order component, be subscribing to that topic. So once there's data coming in on the topic, then the order will be triggered into action. So then your order, in this case too, the order itself gets the order, it will process it, and probably when it's all good, then it basically update the information. Now, let's call it just some information. It can be a database, or you can actually use event sourcing to help you with that. So once you kind of get the order created properly, it also emits an event called order created event. So order event created event can be listened on or subscribed to by, let's say, an inventory check component and a credit check component, because these are important in your shopping cart operation, that you need to have your warehouse be there to know that, okay, there's some order coming in. So the inventory check will go and make sure that you have the goods that are being ordered, available in your warehouse. And then at the same time, you also want to do credit check on the person, on the customer buying the service. So it kind of, as you can see, it kind of keeps kind of going down in here. But at the same time, too, as you can see, while they are being processed, I'm checking the inventory, I'm also checking the credit. Then in the meanwhile, too, you also actually have updates to update the status of the order as well. And as you can see, this is all kind of self-driven, it's all event-driven. It emits event, and it will trigger action in the downstream kind of processing too. So let's say, right, in this case, inventory is all checked. It's, I have the goods you're looking for. And also the credit of the consumer is all checked. He has full funding in good standing. So in that case, then I have the checked status indicating everything is good. Then it goes into the payment processor. So then now I know the payment says, okay, good. Now I can actually process the payment like that. And then at the same time too, I can also go back to updating the order at the same time. So everything, too, is all being triggered by events. You don't need to have explicit processor to do it. And OK, so all of these things towards the end, as you can see, when the order is paid, then you can actually then be listened on by the shipping processor. Then the shipping will kind of get ready. OK, I'm going to start getting ready now. I know that my order is good, and then you can go ship for it. And OK, so as you can see over here, too, I have a note that says there's also compensator microservices. And as such, too, that's one thing I think is still being worked on, is that because of the rollback kind of mechanism, or not rollback, but kind of compensator mechanism for cases in which it doesn't work, then you also have to write microservices to handle the compensation part. So that might be something that's kind of still being worked on from what I have kind of heard. I have not had a chance to implement it, so can't speak to it yet. So okay, so that's that. So that's just an example. So let's kind of go back in here now, because we only have a couple of small minutes, right? Yeah.
Yep.
Okay, we'll bring up a bit of reactive too.
Yeah, so you might be thinking about those original cloud-native methodologies, those original behaviors from Netflix. And actually, the Reactive Manifesto fits quite well into this. And this is another sort of level at the programming level and at the architecture level, another methodology that you can take a look at to start implementing into your own application. So this was created back in 2013-ish, and essentially it's 4 key characteristics that define what we expect from a reactive application. And there's a bunch of different libraries you can use for this, including things like RxJava, which really help to implement these behaviors at the programming level, and then things like MicroProfile reactive messaging, which is another MicroProfile specification that enables these behaviors, again, at that sort of coding level. And for those of you who are keen-eyed, you'll have noticed that each of these does relate back to the, can you guys see that? The extra text? I can't see if you can see it from here. There it is.
There.
So yeah, it links back to those original 3 characteristics that we had from Netflix of what a cloud native application is. So we can also utilize reactive for that as well. I think we're tight on time.
Yeah.
So do you want to skip the, or do you want to do it?
Oh yeah, sure. Yeah, maybe.
We can do the demo and then...
Yeah,
okay.
real quick, right? So, but if you want to follow along right now, you can actually go to this openliberty.io/guides, and that's where you can find a whole bunch of examples too. And we specifically want to take a look into, or point out the persistence lab that we have. So, over here.
Yeah, so you can find this all on the Open Liberty website. So if you're not familiar with Open Liberty, it's an open source cloud native runtime. And it implements things like Jakarta EE, MicroProfile, and a bunch of other open source Java libraries and technologies.
That's right.
And as Mary mentioned, this is in the guide section.
That's right. So maybe we won't have time to go into there, but just wanting to point out to you, guides have a lot of exercises you can put your hands into. So that's something you can take home with today. Okay, so for today's, you can go into persistence. And over in persistence, there's a caching HTTP session data using JCache and Hazelcast. So there's an example too right here. But as such, I know we only have like a couple minutes, so I won't get into all the details. But you can do it, and there are also the cloud version that you can try out interactively. Or if you already have Java installed and just couple things like Docker. If you have installed, you can actually follow along, and it gives you instruction on over here how you can kind of, the source code is already there, so it gives you instruction. You can just copy them onto the command line, for example, and run it on the command line shell too. So, and it supports Mac and all the common operating system, right? Linux and Windows too. So, okay, so that's that. But I also, at the same time, wanting to point out too, because I work with Pulsar. So Pulsar too, let me kind of do a really, really quick introduction here. So Apache Pulsar, right? It's actually a, you might say, how many of you are actually using Kafka? May I ask? So yeah, quite a few too. So that's cool. So this too is that Pulsar, I wanted to point out, is really an Apache software that's actually extending Kafka, because Kafka as such is not designed from the ground up as a cloud native type of scenario. Think of the fact that you need to scale it. Then you need to kind of, because you already have to figure out your partitions, all of your topics, the fact is that Pulsar is designed from the ground up from a cloud native perspective. So it does all of the rebalancing of all of your partitions or your topics and brokers and everything. It does it for you already automatically. So then you as a developer, you don't need to worry about that. So I want to kind of point that out, because I recently started working in DataStax. I realized, wow, this is really big. Being able to do rebalancing is really good. Now, so the way that why it is can do so good is because it separates out the compute and also the data storage part. Now, in Kafka too, it does everything together. You have the compute and managing the distributed logs all in one itself, right? Or maybe it's using Zookeeper, but I think maybe it's not using anymore. But Pulsar itself too relies on Apache Bookkeeper to help with the distributed logs, and also Zookeeper for managing the clusters, all of these things. So it's a bit kind of more efficient in that sense, and it scales really well, does all of the rebalancing. And also here too, multi-tenancy and geo-replication, everything like that can be done on the configuration level too. So, but again, I won't have time to go into all the details, but wanting to invite you to join. And there's also a Astra Cloud too, which is actually managed Cassandra in the cloud. So at DataStax there, we have also implemented the streaming in the Cassandra cloud that you can actually do, but let me kind of really, really quickly. So here I'll give you oops, kind of like, let me, do I have time? Yeah, all right, just real quickly. Oops, actually, it's not that, I'm sorry. Sorry, it's whenever there's okay, maybe I won't have all the time to get through to here.
Yeah, I think we've only got 2 minutes.
Okay, so really quickly too, if you want to do streaming, all of these things, again, it deals with also persisting and all of these, and it does a really good job. So if you can actually create stream over here, for example, things like that too, to create your data source and everything. Okay, so with that, it's just super quick. So wanting to introduce that. And then with that, we can kind of close this out, right? It's just 2 minutes.
I feel like we've exhausted you, but just in case we haven't, here's a bunch of resources that you can check out if you're interested in following this topic along further. It lists a bunch of the stuff that we've sort of been talking about throughout this presentation. You can also go on to our more sort of broader topics on IBM Developer, for example, and check out more about the Pulsar project that Mary mentions and DataStax itself. Yep. You can also check out the Managed Cassandra on various different cloud platforms, depending on what you're interested in. Join our community. Again, loads more links for you. We will be having these slides online, so don't feel like you have to take pictures. Mary's got a Twitch. Go and check that out. This is a whistle-stop tour. And then join Pulsar. Thank you very much.
That's right. Oh, all right. Zoom through. Thank you. Okay.
I think we've only got 1 minute.
Yeah, okay.
Okay. Any questions now? Otherwise, we'll be hanging around the conference all day, so you can come and chat to us afterwards as well.
Yeah.
Cool.
Good.
I just blew you away with all those resources.
Yeah, that's right. It's cool to see.
Well, we'll put the slides up online, and you guys can access them there.
Yeah.
Thanks very much, guys.
Thank you. Yeah, thank you. Okay.